So now we were talking about how in order to use KNN, all the predictor attributes have to be numeric. But there could be scenarios in which you will get a data set in which not all the attributes are numeric. For example, some of the attributes may be things like gender, or you may have an attribute that represents the education level of people, or you may have an attribute that talks about the age group, whether the person is a child, youth or adult, something, right? So not all the attributes may be numeric, in which case we have to convert that. Okay, so clearly, in order to use distance, we need numerical predictors. What to do if your predictors are categorical? There's a very simple technique to do that. So for example, here is a data set in which income is our target attribute, but you've got three predictors, out of which one predictor is categorical, status, right? So what do you do about status? Now, sometimes people may just say, well, why don't you just encode it and say student is 1, unemployed is 2, retired is 3, employed is 4, something like that. Just assign a number to each of them. And then, well, it's become numeric. Status has become numeric. Well, that really doesn't make sense, right? Because if you put a number and say student is 1 and unemployed is 3 and retired is 4, then by treating those as numbers, you're ascribing relative values to those levels. You're somehow saying that retired is greater than student, right? Whereas there is no such thing about this being greater than that or less than that. Operations like subtraction, multiplication, division that you would do with numbers don't apply to these numbers, because these numbers are just indicative of categories. It's not truly numeric. So we have to be very careful when we just because we could put a number on something, we cannot treat it as a numeric variable, right? So just naively putting numbers is not the trick. It's not going to do the trick. Okay, so what you do is you're going to use something called dummy attributes. Okay, so we're going to use the technique that creates dummy attributes, and dummy attributes will convert all of these, will create a number of 0, 1 columns. Okay, those are truly numbers that you can actually treat as numbers. Okay, so here's an example of dummy attributes, the same example. So this data set with status as a categorical attribute will become this. Okay, so notice what has happened. What has happened is the different levels of this attribute of status, student, unemployed, retired, employed. There are 4 levels, right? Those levels have now become columns in this new data set. So there is a column called student, unemployed, employed. Okay, now it's for a good reason we have left out the 4th. We'll come to that. Okay, so all these values become columns. And notice that for the first row, the person is a student. And therefore, for the first row here, student is marked as 1, all others are marked as 0. Okay, the second row is also a student, so student is 1. The third row is an unemployed person. Notice that for the third row, unemployed is marked as 1, the others are marked as 0. Okay, so this is what you do, right? For a particular row, the level of the attribute will determine which attribute becomes 1, all others will be 0. Okay, so that's what works. Okay, so the different values of the categorical attribute status have now become columns or attributes with 0 or 1 as the value. All these values will be 0s or 1s. Okay, but the important point to notice is that there are 4 different values of the attribute status. We are using only 3 of them. Okay, the reason is once you know the value of 3 of them, you already know the value of the 4th. It's redundant to include it. Okay, in some techniques, when you include redundant information, it gives trouble. Okay, for example, in linear regression, if you use something with a redundant attribute, linear regression will not even work. Okay, and also why include redundant information, right? So for example, if you look at this, this is 1, 0, 0. What is the level for retired? It's obviously 0 because this person is a student. And only one of the set can be 1. This is already 1, so the new one has to be 0, right? Or if you look at a column here, for example, this row with the age 58, 0, 0, 0. Well, that means the person is a retired person. So automatically the fourth one is a 1. Okay, so including that would be redundant. So that is why typically when you convert to dummies, you leave out one of the levels. You don't use all of the levels. Of course, we will be using software to create the dummies. The software will create dummies for all of them, but when we build our model, we will carefully eliminate one of them. Okay, so the status for this row, as we've already discussed, is retired, because all these three are 0. Naturally, that has to be 1. Okay, so here is an attribute called gender, and it has the values F and M. Okay, so if you want to convert that into a numeric attribute for use with KNN kind of methods, then obviously we'll have to create a new data set in which there is a column which is F or M, right? We won't include both because we don't want it to be redundant. So we'll have one column. So for example, that column might be F, and for all females, it'll have a value of 1. For all males, it'll have a value of 0. That's it. Okay. So when you're doing computations, because these values are only zeros and ones, there is no other thing, right? So all you will be doing is, when you're calculating distances, you'll be just calculating the distance, 0 minus 1 or 1 minus 1 or 0 minus 0. That's it. No other operations are performed. So even though 1 is greater than 0, the fact that it's greater than 0 is not going to play a role in your computations. Of course, in order to use this data set for KNN of any kind, regression, in this case, in fact, the target attribute is income. If you want to use that, you will first have to standardize these two attributes. Okay, so if you're using KNN and if you have categorical input predictors, convert them to dummies. Okay, so KNN for classification requires a categorical target, and if your target is not categorical, consider binning, which we will talk about. Okay, the target attribute has to be categorical because you're using KNN for classification. Now, sometimes you may have a categorical attribute which is numeric, but you want to use KNN for classification for whatever reason, then there is a technique called binning, which you can use. I'll be talking about that just now. Alternately, of course, you may say, well, I don't want to do that. I'll use KNN for regression instead. Okay, fine. If your predictors have to be numeric for KNN, as we've already discussed, well, if you do have categorical predictors, then now we know how to convert them to numeric. You have convert them through dummy attributes. So let's look at this technique of binning. In other words, you've got a numerical target attribute, but for whatever reason you want to use KNN for classification, then obviously your target attribute has to become categorical. So binning is a method by which you convert a numerical attribute to a categorical attribute. Classic example is, let's say grading. So you've got original, these are some values of a numerical attribute. So obviously you can convert them. You can say, well, between 0 and 50 is A, between 50 and 100 is B, between 100 and 150 is C, etc. So then you can classify all of them like this. You can just bin them, right? So the first value is B because it's between 50 and 100. 60 is between 50 and 100, so we put it into a bin. Okay. Of course, you have to be careful when you determine how exactly you create these bins. It depends on the context. You can't just randomly do something here. Based on the context, you may say this. So for example, suppose you've got income as your target attribute, and the income values are actual numbers. But for your purposes, you want to, let's say, simply classify the income as high, medium, or low. Well, then you will determine the levels at which the income would be considered high, medium, or low. Okay, so you might have to analyze the incomes a little bit, see the patterns, and then see whether there are natural breaks somewhere, and then say, okay, this is low, this is medium, that is high. Okay, so that is how you do binning. So now here is a data set where we looked at income and lot size. We're just looking at a data set. We looked at this briefly when we looked at when we were doing classification trees. This is borrowed from this particular book. Okay, so you've got these two predictor attributes, and that's your target attribute. Before you can use KNN for classification, you have to normalize both of these. and the data set that you will actually use for KNN will look like this, right? In other words, once you have found the normalized values of your predictors, you're not interested in the unnormalized values, okay? And typically, we don't try to normalize dummies, right? Because the dummy variables, dummy attributes all have values of 0 or 1, okay? So it's pretty close. The averages will generally be, pretty close to either 0 or 1 or be somewhere in the range of 0.5. And the other normalized attributes, all of them will be having an average of 0. So these are all pretty close to each other. So we generally do not normalize or standardize the dummy attribute values that we have calculated. We only normalize or standardize the other values. Okay, so going forward, we will not be using the actual column income and lot size. We will only use the normalized income and normalized lot size. Here in this example, I'm using normalized values. But in a different example, you might not use normalized. You may just scale it, right? And put the minimum at 0, maximum at 1. That'll also work, right? So you could either standardize both the attributes or you could scale both the attributes. Either approach is fine.